anytime we talk about intelligence and ideas about how it should work, that should be able to be implemented in a computer. And I'm going to have a whole series of implementing intelligent behavior in computers. Some will use regular computers, but some are going to use these special computers called Raspberry Pis. What is a Raspberry Pi? Well, other than the one that you can eat, it is a single board computer. What is a single board computer? Why, it's one of these. Look at this. This is an entire computer. Now, it doesn't have a keyboard or a monitor, but it has everything that you need in a computer. There are other brands of single board computers other than Raspberry Pis, but I think the Raspberry Pi is our best bet. One, because they're very popular. If you're having trouble with it, the odds that you'll find some help on the internet are very high. Also, it is a full computer. There are some things out there like Arduino that are computer-ish, but they're really specific pieces of hardware made to make animatronics and art installations. And if we're going to explore intelligence, I need something that runs real high-level programming languages. Also, you can find some small computers out there if you want to build your own laptop or something like that, but they're not going to interface with electronics hardware very well. The Raspberry Pi has these pins. They're called general purpose input-output, and they are a way to program this computer so that you can control simple electronics, lights, motors, sensors, that kind of thing. The Raspberry Pi that we're looking at right now is the Raspberry Pi 3. You can see it's written right here, Model B. But there are several other models. Most look very much like this. You're going to see, this is the power, HDMI, exactly the same kind of HDMI that maybe your game console uses. No idea what this does. We have an Ethernet port and 4 USB, plus the GPIO pins. The other thing I really want to mention is this and this right here. These are camera slots. They make a special Raspberry Pi camera that plugs in. I have one right over here. This is a Raspberry Pi 1 with the camera slot attached. And even though this is a Raspberry Pi 1, you can still see it has the exact same power, HDMI, Ethernet, USB, camera slots, and GPIO pins. So that's nice. The main difference between these two is if you look at the back. This is 8 gigabytes of RAM. That makes a big difference in the performance of these. Now, there are several other form factors. The first one I'd like to show you is called the Raspberry Pi Zero. This is a $15 computer, a full computer on a single board for only $15, which is impressive until you realize all of the accessories that you also have to buy to get it to run. Also, we could see that the inputs and outputs are a little different. The GPIOs are the same. There's one camera slot instead of 2. There are no USBs. This is the power. You can see it says PWR right there. And you get one micro USB. So you're going to need a splitter to do anything useful with that. This HDMI is not regular size HDMI. It's a mini HDMI. You're going to need an adapter or a special cable. The last type of Raspberry Pi I'd like to show you is one of these. This is a Raspberry Pi 4. And the Raspberry Pi 5, which is out now, is very similar. I put a heatsink case on it. These are more powerful computers, so they're going to need some extra sort of cooling. The Raspberry Pi 5 requires a fan. But you could still see the exact same GPIO, 2 camera slots. Ethernet's on the other side, but now you have these special high-speed USBs. And on the side, here is the power. This is different. This requires special power. And these are two HDMI slots, except they're micro HDMI, so you're going to need adapters or special cables. Now that we've seen the basic Raspberry Pis, let's get one working. I have a Raspberry Pi 3 here. Should be a good one to start with. So let's plug it in. The first thing we need to plug in is one of these. This is a micro SD card, 32 gigabytes. I recommend 16 should also be okay. And plugging it in is easy, but we have to get the Raspberry Pi operating system available for that. So I'm going to plug that into my regular computer. So you can get a Raspberry Pi 3 for $50, but you'll have to flash the SD card with a real computer. Mine cost $1,200. So that's a minor accessory you might need. I'm going to use the Raspberry Pi Imager. Choose device. This is the Pi 3. The operating system, I'm going to go with Raspberry Pi OS 64-bit. The Raspberry Pi 3 has 8 gig of RAM, so it should be able to handle that pretty well. And there's only one piece of storage listed, which is good because I don't want to flash my hard drive with this. It says 32 gigabytes of storage. That's the one. Let's click next. No. It's going to be erased. Okay. Well, that took a minute. Now all we have to do, pull the card out. Huh, looks the same. Who'd have thought? And let's pop it in. Step 1 done. We have our hard drive installed. Now all we have to do is just plug in everything else. Let's do the keyboard next. I have a wireless keyboard. So all I really need to do is just plug this guy in. Good. If you have a wired mouse, USB mouse and keyboard, you should be able to plug those in, no problem. Let's get our HDMI cable. And lastly, we'll plug in the power. It's tricky to do this on a couple of different cameras. There we go. The red light means the power is on. The green light is when it is accessing the SD card. Now, we wait. Welcome to the Raspberry Pi desktop. Lovely. We'll have to do a few things just to get started. Select your country, your time zone. That looks right for me. Oh yes, for some reason it takes forever to set the location. I don't know what's so difficult about this. Make a username and password. That's fine. Let's connect it to Wi-Fi. This is just my home Wi-Fi. Alright, let's skip this. It takes forever to update. And restart. That should finish the basic setup. And we are in. So this is a desktop computer. We can come over here and open our web browser. Ooh, it will take a minute to open the web browser. A Raspberry Pi is not I would not recommend one for a normal home computer. They're nice because they're small and we can use them in projects. But yeah, for normal web browsing, they're probably going to be a little sluggish. Some of the newer ones, the Raspberry Pi 5s, might be okay. I set up 4 different Raspberry Pis on the same monitor to compare their performance and the possibility that they could be used as your personal desktop computer. In order to test it, I decided, well, let's open a browser. Chromium is the standard browser that is installed with these. And look, the Raspberry Pi 3B opened the browser in only 13 seconds. A long time for a regular computer, and yet the record for these 4, 29 seconds for the Raspberry Pi 4, which is a little odd. I'm not sure why it's doing worse. I think they have different operating systems, and it's possible that there is an older version of Chromium on the Pi 3 that is slightly more lightweight. The Raspberry Pi Zero opened in 46 seconds. Now, after the browser opened, I did a simple search on DuckDuckGo for Raspberry Pi to see how well that went. Looks like the 3 finished that in 8 seconds, the 4, 21 seconds. So we're getting almost a minute just to open a browser and do a search on the Raspberry Pi 4. Raspberry Pi Zero is still struggling to search. The Raspberry Pi 1 has not even finished opening the browser yet. Wow. Now, the big difference between the Pi 1 and the Pi 3 is RAM. The Pi 3 and 4 both have 8 gigabytes of RAM, which it should be enough to run most modern software. The 0 and the 1 both have 512 megabytes of RAM, which back in the day would have seemed like a science fiction huge amount, but today that is really not acceptable unless you're running very, very lightweight applications. 512 is not going to cut it. Oh, hello, little guy. He's come. It looks like the Raspberry Pi 1 has taken so long that the cat has shown up just to knock off the boredom. And yeah, with the Pi 1, I didn't even bother doing the search. Clearly, 2.5 minutes to open a browser is completely unacceptable. The 3 and 4, in a pinch, I think you could use them, but they're not great. And finally, the Raspberry Pi Zero finishes its search in 1 minute and 57 seconds. Good for robots, maybe. Not great for surfing the web. What you're going to be using mostly is the terminal. We'll just be typing in commands. The basic commands in the terminal. First one you'll want to know is ls, which is short for list. That will list everything in the directory that you're in. What directory are you in? Well, use pwd is print working directory. We are currently in home/cbrosky. If we want to change directory, that command is cd space and the name of the directory. Let's go to downloads. You can look, there's nothing in the downloads directory. Let's go back up one level. cd space ... will take us back up. And here we are in the home directory again. One more command I should show you while we're here is how to install software. There is an application called apt-get, and you use it like this. Sudo means we're running as administrator, apt-get, and then usually you can do an update just to make sure that you have all of the latest lists of software that you can install. Then we can sudo apt-get install, let's install Micro. This is a terminal-based text editor that I really like. Now we should be able to run Micro. Yep, here it is. Let's just quit. I don't need to do any text editing right now in the terminal. So there you go. You have a fully operational computer, $50 for a Raspberry Pi 3, $15 for the Raspberry Pi Zero W, and about $2,000 in accessories. Now, such a bargain. You can't afford not to get a bunch of them. The nice thing is with the accessories, now you can buy as many Raspberry Pis as you want, and it doesn't really cost much more. The last thing I want to show you is to work on a Raspberry Pi, having to plug in your keyboard, your monitor, all that other stuff is kind of a pain in the butt, especially if all we're doing is just working through the terminal. We can create one of those terminals on another computer, and I'm going to show you how. First, you're going to have to make sure that the computer that you want to open a terminal on and your Raspberry Pi are on the same network. Otherwise, they won't be able to communicate with each other. I've connected both to my local home Wi-Fi. And we'll need to know the address. So, if you just hover over this, it's going to tell us IP 192.168.1.219. If you want to find it through the terminal, you can use ifconfig. And here it is. You search for it and all the other stuff that that it puts up. Usually you're going to see it start with 192.168. And whenever a device connects to a network, it's going to give it an IP address. And this IP address, remember the 219. We will also want to enable SSH. So let's go up here to the Start menu, go to Preferences, Raspberry Pi Configuration. There'll be lots of stuff in here you might need to use now and then. Interfaces, SSH. Okay. Now we should be able to communicate with it from my real computer. All right, here is my laptop. In order to connect, all we need to do is the command SSH, the name of the user on the Raspberry Pi, the address, the IP address of the Raspberry Pi. Yes. And the password of that user on the Raspberry Pi. Okay. Now this terminal on my Mac OS is exactly the same as the terminal on the Raspberry Pi. Now I don't need a monitor, a keyboard, or anything. I can have a bunch of Raspberry Pis on my network. I can SSH. I can securely connect to any of them and run whatever terminal commands that I want. So why have I shown you all of this? This is the first in a series of videos that I'm making that will end up with us building an autonomous, intelligent robot. So maybe wait till that's out. That'll be a good video. And then when you want to follow along with the project and create your own robot, you can come back to this one if you need to get started somewhere, if you're stuck with a Raspberry Pi. So check back in the future. You might need this. Maybe you just want to get started with a Raspberry Pi. I hope I've given you enough to be dangerous. And the next video, we're going to be doing some programming on it. So that should be a little more interesting. Until then, care for yourselves and make good decisions.